All right, welcome everyone. We're going to start our panel discussion about how crowdsourcing could basically work for our neuroimagers. We have fantastic lineup today to be here with us. I'm going to first introduce Professor Paul Thompson. I guess probably he doesn't really need much introduction, but I'm just going to do it anyway. Professor Paul Thompson is a distinguished faculty member at the Keck School of Medicine of the University of Southern California, with a profound experience in the field of neuroscience. Neuroscience. Professor Thompson has made significant contributions to brain mapping, utilizing innovative techniques and collaborative approaches. He is renowned for his pioneering work in leveraging crowdsourcing to advance the understanding of brain structure and function, particularly through the ENIGMA, which stands for Enhancing Neuroimaging Genetics through Meta-Analysis Consortium. As a co-founder of the ENIGMA Consortium, he has been instrumental in coordinating one of the largest collaborative brain mapping efforts in the world. ENIGMA brings together researchers from around the globe to pull data and insights, vastly enhancing the accuracy and scope of the brain mapping studies. Thank you for joining us today. And next is Professor Seokjun H. He is Associate Professor in the Department of Biomedical Engineering at Seokjun University, and is also affiliated with the Center for Neuroscience Imaging Research, IBS. Before joining University Seokjun, he was a postdoc researcher in the Center for the Developing Brain at the Chapman Institute in New York. Dr. Hong's previous research has focused on advanced in vivo multimodal magnetic resonance imaging of typical and atypical brain development, especially targeting a large-scale brain network organization. Building upon expertise in computer science, statistics, and neuroinformatics, he developed original approaches to quantitatively describe neurodevelopment and implement clinically important applications. At Seokjun University, based on his learned knowledge, he now expands the research interests to build up more generally capable autonomous intelligent systems with biologically detailed neural network models. Sounds so cool. I guess we're going to have a lot of questions for you today. All right, and then next is Professor Chaogan from Institute of Psychology in Chinese Academy of Sciences. Dr. Yan is a professor at the Institute of Psychology Chinese Academy of Sciences. He is the director of the Magnetic Resonance Imaging Research Center, the director of International Big Data Center for Depression Research, and the principal investigator of the fMRI lab located within Chinese Academy of Sciences. His research mainly focuses on the resting state fMRI, computational methodology, mechanisms of spontaneous brain activity, and their applications in depression. He has published more than 100 peer-reviewed articles, including more than 50 as first or corresponding authors in prestigious journals, including PNAS and Molecular Psychiatry. His work has been widely cited in the scientific community, with the total citations more than 21,000. 6 of his first author and corresponding authorship papers ranked as ESI Top 1 highly cited papers. Has been ranked as 2019 to 2023 most cited Chinese researchers by Elsevier. He has awarded the 2021 Early Career Investigator Award by the Organization for Human Brain Mapping, OHBM. Welcome you all to join us today. So we're going to start with some basic questions because presumably crowdsourcing can mean different things to different people. So what crowdsourcing mean to you? Crowdsourcing. So I don't know who wants to go first.
So I'm actually really honest. So I actually didn't really fully understand the meaning of crowdsourcing before this meeting. So I actually personally check, and it's actually a obviously part of open science, but what is differentiating from open science, more specific to crowdsourcing, is in my perspective, is traditionally data sharing or software co-development is probably based on site-wise or collection, or research institute-wise. Then this crowdsourcing mean to me more that aggregation of those small group of people or even single researcher to aggregate their little power, so that to build up the larger and more constructive effort.
Right. I think that's one way to understand it. It's just like, so people used to collect small size data by themselves. And then now we have seen more and more consortiums with multi-sites. That's also one way of crowdsourcing, because you put data together from all over the world, right? So.
Okay. Yeah, and thanks, Wei, for a nice introduction. I think crowdsourcing has a unique role in brain mapping because I think it used to be that people would collect very, very small data sets. And one impetus for crowdsourcing was the reproducibility crisis. I mean, the notion, and I don't think it was all our fault. I think in brain mapping, it was just expensive to collect large data sets. So if you agree with the premise that larger data sets would give more power, more reliability, more diversity, one solution, it's not the only solution, one solution is for multiple labs to get together. Now, I mean, that's just one part of the crowdsourcing. So that's just a big data set. You could analyze a big data set on your own. I think the other key part is the diversity of ideas. And so all of you in the audience, I'm sure, have worked in a large multi-author paper. And certainly the team with a large number of authors can have more insight and diversity of viewpoints than a single author. And this would be true in neuroscience or mathematics or the humanities. So I think crowdsourcing, I mean, maybe it has slightly different meanings, could mean pooling data, but it could mean pooling perspectives of different researchers. Or it could mean making accessible data sets to the largest possible number of people. And so we certainly know with ADNI, UK Biobank, ABCD, I heard recently that the UK Biobank had over 1,000 registered applicants looking at the neuroimaging data. Never mind all the rest. So that really is crowdsourcing. If 1,000 labs around the world are looking at that data. And so that must be good value for money. I mean, the data being collected, if it's being analyzed by 1,000 labs, that seems like there's an economic as well as a scientific reason to be doing it.
Okay. So in my opinion, crowdsourcing is pretty good thing that we know, for example, brain imaging data, we want big data set. And we know like UK Biobank is very, very good, huge, and very, very simplistic scanners that is not across different scanners. But if you use this kind of single cell data, we train a sex classifier, it cannot generalize to other data. So, but once we do the many Mickles, your title was, okay, anyway, it's a crowdsourcing thing. So we try to gather in data from different parts of the different worlds, and then we can train a model, have practical use that apply to any new kind of data set. We can predict size, we can predict Alzheimer's disease. But without the crowdsourcing, just rely on single huge data set like UK Biobank or like HCP, you can have good results on that data set, but again, it cannot generalizable. And also in our lab, but we just follow Paul's model, the Enigma model is actually crowdsourcing, right? So in depression, we have the direct imaging research consortium, depression imaging research consortium, follow Paul's model. We have crowdsourcing of the data. We have the biggest open shared depression data set. and to moving the field forward. And we all also open shared our software like a DeepIB, and everybody can pull requests, can contribute our software. So it's a good crowdsourcing way, I think.
Great. It seems like everybody is on board with crowdsourcing in one way or the other. So we have a bit specific question, particularly for Professor Chaogan. So then how can we ensure that open software or open data are recognized by our research community, funding agencies, and promotion committees, and thereby empower early career researchers to contribute more to this movement?
Yeah, I think that's a great point. So many of you who are on tenure committees at universities evaluate professors. And let's say someone is writing software. You might be familiar with this discussion. I mean, the software could have thousands of users, but it's not a conventional type of output of a scientist. I mean, they're used to papers, books, things like this. But I think it's changing. I mean, I think, you know, as many of us rely on software for many of the successful projects that we're involved in, I mean, we cite it. We might write letters for somebody who's writing software to help them gain more visibility or organize a session. But I think that's a very important point, because as well as papers, which are very nice, the software is sort of like the vehicle to, you know, essentially empower many, many more people to do what they're doing. And I think you're right. I don't think it is recognized as much as it should be by at least university committees. But
So as you also mentioned earlier, one software involves a lot of developers, right? How should we credit them accordingly or properly?
yeah, I think that's a great point. It's difficult, isn't it? Because if there's a paper, every author goes on the paper. And then if people are counting their papers or their H-index or whatever ways people like to measure productivity, the authorship on a paper is a traditional way of demonstrating that that person contributed. Software seems more difficult, doesn't it? I mean, it's not, every user is not obligated to acknowledge every person's name that is contributing. So I don't know the answer. I think that's a difficult question. You know the answer?
Probably I don't know the answer, but I have some experience that myself is pretty benefit from open science. So actually, my most highly cited paper is a Frontiers paper. Yeah, that has cited me more than 3,000 times. Just back to 2010, there's an invitation, just Frontiers created, sent to my advisor, and invite for special issue, and we have a software, so we just whatever publishable just goes there. But for this kind of open source software, so many users, they will set it, so it's always highly cited. And later we got DeepIB published in neuroinformatics. It's always ESI top 0.01%. It's pretty highly cited. And also we have the data paper. So we openly share the depression imaging data. It published at PNAS, but itself is also 0.1% highly cited. So we have lots of highly cited papers. This is because the spirit of open science. We openly shared our software. We openly shared our data and shaping the culture. But it comes still the other question that how get those to have high evaluation. But myself, I cannot argue that, because I got the early career investigator award at OHBL, and in China also got some tenure evaluation. But I just worry about the young generation, that for those people, they spend so much time, like Seokjun, spend so much time in the open science, in the software, and in data. If I was on the tenure committee, I will give you very high score. But how to persuade the other committee members. In China, it's not good because in China, it's always counting the impact factor. And usually for open science, cannot reach that high as Nature. It's not like you Enigma can get Nature papers, but for otherwise, it's very difficult and pretty difficult for tenure committee. But to me, is I will try my best to use my influence to impact other reviewers on the committee and try to weigh more on the open science part.
Yeah, I think actually what's happening in China is exactly happening in Korea. We also count only like number and impact factors. It's really sad. I think all this discussion probably just boiling down to the credit assignment and how we're gonna give an incentive to those who actually contribute to people. And then I think there are multiple domains that have to interact each other, like a funding source, research institute, and then government, etc., and journals actually. So that, for instance, funding sources, whenever they apply the grant, and if they get, and then it turns out that they actually contribute either data sharing or software contribution. I personally believe data sharing is now should be almost just mandatory, but then it turns out to be like that case. Then next round, the funding source can give a slightly higher scores to those applicants, so that in that way, the funding source can reinforce the people to contribute more. So that I think that kind of policy should be built across the board.
Yeah, I think that's actually happening, at least within the US. So NIH now requires, so they launched this data sharing plan from early this year. So it's still kind of in the trial phase, but they are tightening the policy, asking everyone to share. For example, as an NIMH, you will have to share your data and also on their platform. Although that platform is a disaster, but you will have to.
On that side, I do have a question for you and for Paul that in China, the NSFC or NSF, that we do not have any mechanism to funding software developing. At least to my knowledge, I do lots of software, but I didn't get any funding for that. Is the US has the fundings for developing software like Afani, like your Enigma, HalfPep, right? Like that, developing software, open source software?
That's a great question, because most grants scientifically are to answer a question. And the question has to be a health question if it's NIH, or a scientific question if it's an engineering grant. Within the US NIH system, there is one agency, NIBIB, which is a biomedical engineering agency, and they do fund grants that create an algorithm. And so, I mean, you would say, I mean, many of the tools you're developing, Chaogan, I mean, that would be a natural grant from NIH. On the other hand, though, NIBIB does not have a very large fraction of the NIH money. And for that reason, the pay line, the percent of grants funded, is actually rather low. The other agencies have a better pay line. So if you are advising a junior researcher which grant agency to apply to, you wouldn't necessarily recommend one where the percent funded is low. The other way, Chaogan, that I've seen that software infrastructure is funded is a program grant. And so these are larger grants like a P01 or a U01, where people do hypothesis testing, but then there's sort of an administrative component to the grant that might store the data, curate the data. But they tend to be limited in the sense that when the grant ends, I mean, what is the support then for that data? So I think, Wei, you made a good point. NIH has tried to solve that. I don't know if they fully succeeded, because when a grant ends and the data activity ends, I think the NIH would like it to be the case that all of the valuable curated data is maintained, supported, disseminated.
Yeah, I think that's probably why partially the data storage platform they are running kind of is bad. Sorry, I almost said another word. So I completely agree with you, but I do think it has to start from somewhere, right? So it seems like NIH is aware of the situation, and hopefully the leadership will be aware of even more questions now, problems now, and address them one by one. All right, then we can probably go to the next question. Oh, we actually also have a, online speaker. But is he on the screen? Because we haven't heard from him.
Hello, hi. I guess you hear me in the background.
Because we forgot to put you on the screen. Do you have anything to add?
Yes, actually, I would like to add a bit on the incentives. I totally agree that we need to incentivize and we need to find ways to have, in general, crowd contributions recognized at a faculty level and during evaluations. But in the end, what we can do now, let's say as developers and not as big professors that evaluate people, is to try to leverage a system in which everybody gains from participating in crowdsourcing projects. So what I like to say is that I like to create systems that make people altruistic for selfish reasons. This means they immediately gain something by contributing to the system. And this is, I work on, I would say, crowdsource segmentation. So people can, people have a software and they can use it for their own research, for their own purposes. So they can create their own paper by using this software. Sorry, there's some problem with the video. My camera is on, but it doesn't appear. I think it's maybe a connection issue. But I will try to fix that when I finish speaking. So I was saying people can use this software, and while using it, they also contribute to it. And this is the immediate goal. So whenever people contribute to something, we should make it so we as developers of systems that leverage crowdsourcing, we should think of direct incentives, because in the end, if we are thinking about large scale open source projects, they might have thousands of contributors, and in the end they cannot all fit in the paper, and maybe they cannot even be all equally recognized, but they can receive benefits directly from the project itself, and it might enable their own research that can then be counted.
Right. I think similar discussion was came up yesterday as well. I think one, I don't remember the name. Forgive me if I forgot your name. Someone mentioned that we probably could consider to ask funding agency to require every single $1 a researcher received will pay half to the software developers, something like that. But unfortunately, of course, that's a bold move. But the idea is basically to have something concrete, right? So something that's gonna, we know for sure is gonna credit software developers. But unfortunately, we don't really have any funding agency people here this year. So hopefully next year we will try to do a better job to invite someone in the house.
Or is the details matter, right? So that I think each country could make their own like incentive system, but I personally believe it should be actually globally consensus. But I just, you know, without any really concrete plan, I just shout loud. But then from those leading researchers should gather and then somehow make this system globally that, you know, how we're gonna give this incentive to software developers or data sharers, so that, so it should make some kind of global standard consensus.
Yeah, please come up to the mic so people online could also hear you. Yeah, I forgot to mention, feel free to interrupt if you have questions, come up and ask.
Yeah, About the sharing, the incentives for researchers to collaborate on existing software, for example, I don't know if there would be a way. I don't know if you know, like fMRI prep. There is like a reporting of the steps that were used in the preprocessing. I don't know if there would be a way to add. I mean, of course, it requires development, so it requires fundings for the programmers. But if we could add to the reporting system also a citation system for each step that is used. So, because of course, if there are like hundreds of contributors to each repository, it's difficult to cite everyone at the same time. But maybe if we had a specific reporting, we could add the citations for each module, and then we would have the contributors. So then it would be maybe a good incentive for contributing, because we would be cited every time we contribute. That might be difficult to implement, but maybe we could go towards that.
But it is not the current standard. Whichever in the all the flow use the software, you have to set them.
Yeah, but I think it needs to be easier to cite, because, for example, like recently, I was finishing a paper, and I was like, well,
you can copy, but you can just copy from the fMRI prep reports, or copy from all
what
paragraphs.
I mean is that fMRI prep is well designed.
Yeah.
So of course they have a big team, and it was well designed, but it's quite difficult to do that for smaller software, and then that means there is less incentive to contribute to smaller software. So it's kind of a vicious circle. If you're in a small team with a small software, there is no system to do that. So that would be nice at some point to have like a standard to do that. So I agree that in some software it's already quite like that, but you know, like we all use, when we do Python, we use NumPy or SciPy, and very often we don't see it cited. And that'd be nice to have a reporting system to do that, I think. Thank you.
I'd actually like to follow up on that a little bit more, to kind of bring in, so not a lawyer, very far from it, but there are, of course, like the software development community, like writ large, has been around for quite a while, and they've established really quite thorough like legal frameworks for licensing code. So your like standard MIT license, right, is a thing that I think we're really familiar with, but the CC BY, CC non-disclosure, all of that. So like there are frameworks that exist for software in particular, and many of them actually do require citations as a part of them. And that actually really does go down in the deep nesting. So like not just at the level of FreeSurfer, but the linear algebra package that underlies it, for example. And one of the things that I'm often confused about is why there hasn't been more of a push to like, I think, promote those kinds of things, just the sort of standard licensing structure that exists for software in particular. I mean, it is a creative output that we're all producing, and I'd be curious what your thoughts are on that. Is it like an education thing? Is it just need to like find the time to do it? Because I mean, in some sense, it's like also a legal requirement, at least within the US, that I'm not sure that we're all following.
I guess Paul, as the most senior person here, also overseeing a lot of journals, what do you think journals could do to promote this?
Yeah, I mean, I think, Patrick, I really agree with your point. I think all of us can play a role in making sure that what you said is done. I mean, all of us are reviewing papers. So if you see an opportunity for a researcher to add credits, now you made a couple of distinctions. I mean, if there was a paper to cite, we could have them cited. but the whole development chain and development stack of code is very complicated. So I think all of us can enforce fairness. I mean, if you see an algorithm published that clearly relies substantively on someone else's work, I think we're all reviewers, and this is one of the benefits of peer review. But I think you're making another important point. I mean, might there be a better infrastructure where code can cite the provenance of all of its elements? And like you said, the lawyers seem to have sorted out, but not quite the academic community. What do you think?
Myself, as a software developer, we maintain several softwares. At least since citing itself is not quite a problem, our users usually will, or at least for myself, the citation is enough. That not I didn't catch chasing after people that you use my software, you didn't cite me. But I think still the problem is, even you have citations, it's still not recognized by the funding agencies or by the tenure committees. You see, even these 3,000 citations, but you do not have a Nature paper.
Thank you so much. Really interesting session. I just wanted to build up on the prior question, actually, which at a kind of broader spectrum, I think is kind of alluding to what we can learn from industry software developers. Like almost all of us were researchers before we were software developers, and yet now I probably spend more than half my time making my software ready than writing the paper in 2 minutes that then attracts citations. You know, for instance, just now you've made the comment about citations or journals as a quantity of impact. But if we look to, I don't know, Apple or Microsoft or whatever, they're quantifying downloads of Excel or uses on OpenAI. Likewise, another comment was made earlier about maybe we should remunerate or pay these developers some sort of royalty for money, which then attracted laughs. And yet, if we look at people like NVIDIA, who have given kind of stock options to their employees and are now millionaires by putting time into building software, which attract further growth that they then, you know, I'm from the UK, and so their company is now worth more than the UK kind of thing, because they've invested in people to build software. And I suppose that's my kind of question more globally about what do you think we can learn from industry in that way that we can advance our own domain?
I think you just answer everything that we have to discuss. I think that, so only remaining part that we have to figure out is not just impact, like recognizing not only impact, but actually how we're gonna give incentives to people. In the end, it's unfortunate for me to say this, but it should be like either funding or something, so that it's actually literally we'll benefit out of this impact, like so-called. So that.
So if you were a funder or government organization, what would you, I don't know, for instance, in the UK, we have REF, which is like government UK framework for how much funding universities get. It's based on papers and qualities of where it's published. If it's Nature, you know, the university gets 12 grand a year, 12,000 British pounds per year. But maybe we would have the same via GitHub stars or whatever. I don't know. But I don't know. Like, what would you do if you were the funder determining?
I think like everything that you just bring up now are totally unclear. So that I think what we have to do is probably like valuing what is equivalent to what.
Yeah.
That, like, I probably give too much number-wise mentioning, but 100 citation is equivalent to like, I don't know.
Yeah. Okay. Yeah.
That these kind of detail, so that personally I believe all matter is actually details. The detail we should build up, and then this detail should not be discussed within country, but across all different countries.
Need like a currency for downloads and use kind of thing. Yeah, interesting.
Let me show you some example or experience. When we talk about industry examples, we are not just carrying citations, we also carry the money incentives. So my example is, we didn't make a lot of money, but when we download our software, there will be pop-up that would you like to donate for us? But I tell you that almost nobody donates. Probably because researchers are not that rich, so they will click and download the software, and the other page donations, they will just close it. But there's one incentive. The second incentive for us is our software, although it's very easy to use, but we created a MOOC, or online educational course, for people who want to learn it. Yeah, it's totally free, it's online. But somebody still, I look at your online course, but I want hands-on training, or I want to have interactive discussion, because sometimes they will, if they don't organize their data well, they will get errors in MATLAB. And they want somebody to answer their questions. So there's one way is we create about more than 3,000 people WeChat group, like a WhatsApp group, and the people can answer questions there. And every month, I will have an online Q&A session. Everybody have questions on my software. I will answer that. That's for free. But for money is I will create 3 days workshop for anybody who has money and who want hands-on training. They can come to my workshop and they will pay a bit of money, and that makes me make a bit of money. But this is just for training, and they come to my educational course, they pay the fee, and they learn how to use it, they train how to use it. And other industry or commercial more Python, I don't know yet. But this at least made some money from the educational course training. But every education course we will record it, and after the training workshop, we will release online for people to free watch. But still, people sometimes they want to come, have the hands-on training, they pay the fee.
Just maybe one thing, because it's inspired, James, what you were saying. There is a path to monetize software development that maybe not everyone here knows about, and you can stay in academia and do it. So we had an experience where a lot of our programmers were developing AI methods for radiology. And so in neuroimaging, maybe you develop an AI method. You have one that's terrific for detecting Alzheimer's or stroke or embolism. And radiologists want to do this. So I was looking into, could you commercialize this? Could you either have a startup? Could your postdoc leave and have like a one-person startup? And one way of doing it, which I think is quite attractive, is to do an academic industry partnership where the industry partner does all of the stuff that we don't know how to do, like, you know, finding the consumer base, the constant support. I mean, there are certainly radiology companies that provision enterprise level software, but what they lack and that we have is the ability to constantly stay on top of the field, develop new stuff, write new algorithms. So there's a huge appetite, and I'm noticing it recently from drug companies like Biogen or software companies in radiology, to partner with academia, because they simply don't have enough money to hire all the researchers in this room. Yes. But if they can do the commercial bit and you can do the software development bit. Now, I'm interested how the finances work. So one model that a radiology company suggested is, they said, oh, well, we market radiology software across the world, and the algorithms are licensed. If you have an algorithm that detects an embolism or a stroke or something like that, someone might pay in US dollars $20,000 a year. So the originators of the algorithm can be paid an annuity from that. And I asked a few people, does that work for you? But I think, Chaogan, as you said, the amount of money coming from it, I mean, I didn't notice anyone that was making a fortune, but it's not negligible. I mean, I know colleagues who've done this where they do have some income coming from it. But what I like about it is a relatively low investment from the academic researcher to partner up with a company, whereas having to make the shift to industry and doing all of the regulatory and people management and licensing yourself would be very, very difficult. So that's another possible path.
Yeah, and from the UK, that's very much where we go, right? We partner with industry to get it done in our lifetime. Ultimately.
May I add something a little bit going back to the academic incentives, just as a general comment on this. I think academia has been living in a bubble where we count our papers, paper citations, impact factor. The reasons for this bubble are multiple, of course, commercial interests, laziness, but I think we have lost a bit of sight of what is really important and what makes really difference in society. And academia is changing. I think that new evaluation principles, at least in Europe where I am, that I can see, are putting more importance over what is making really an impact, what is making a difference. And so in the end, we are ourselves part of committees. We are part of the change. So I'm not saying that the solution is already there, but be optimistic, because it's coming more and more that academia is also going to recognize software contributions and contributions that are different from just simple published paper, because we have seen the shortcomings and the reproducibility crisis that has been cited definitely gave a push towards this kind of new approaches.
Hello. Yeah, thank you for the awesome discussion. I think it's especially the kind of topic of software and where we are going as a field is really interesting, especially since kind of we as a field are kind of crowdsourcing lots of different softwares for the same purpose. So I was just wondering, how do you feel about, for example, when labs have a new question that they just build their own tools and then put them out there, because there's probably a million different fMRI processing pipelines. There's so many different tools that do the same thing, and the same now with AI, that there's now the same or different AI tools do the same thing. So how can we as a field like come together more and be more harmonized?
That's actually quite a difficult question. Michael Milham, who is also a supervisor or mentor, including him, many leading researchers actually try to harmonize what are the optimal pipeline is to process resting state or structural MRI. But then I think it's chicken and egg problem, because if nobody actually developed, then there's nothing that you can make the consensus. And then the other way around, if you just let them just develop, as you said, you want that each lab can, their own software, which probably may feel quite confused. But I think, like theoretically, there should be some almost like mandatory consensus around to, what are the actually harmonizing, the proper harmonizing step to somehow lead the newcomer, not really confused, but then just follow the standard pipeline. I mean, that's a difficult question. I don't think I answered your question.
And I think the softwares will compete with each other in the field. And some will feel, even at the beginning, that cannot attract users. But some will build like Alphany or FSL, they will build step and more users. Our software also has a large user group, and you need support, and you need Q&A, you need to train people how to use it. But they will compete with each other. But also, the nature human behavior mapper is also a good evaluation. But still, I think in the end, it's the ground truth. We do not have a ground truth of our brain function. So it's difficult to see which method performs the best. But in the future, in my mind, is if we're using AI, for example, the best way to predict brain size or the best way to predict MDD or any others in the practical use, which method performs the best, that's a winner, and we should use that. And so.
Okay, I realize we have been talking a lot about software, but crowdsourcing is not only just about software, right? Doing collaborative projects is also one way of crowdsourcing. So I just wonder, how would you recommend or suggest like early stage careers researchers, including PhD students, postdocs in your own lab, to initiate collaborations with other people? Do you have any thoughts on it? Would you recommend? Not recommend? How?
I'll have a go at that. The best way is to come to a meeting like this. And so you will present and meet I don't know, dozens of people. And I always remember, I mean, I've worked in this field for 30 years. Every new project that I started to work on with a new collaborator was a random meeting, an unplanned meeting. Maybe you guys have had similar experiences here. So when I was a student, we worked on Alzheimer's, and I met someone at a meeting like this that worked on brain development. And they said, oh, these tools that you've developed for tracking atrophy, let's look at growth. And then meeting someone else, we started to work on genetics. And then but none of this was planned. So it wasn't as though there was a to-do list, meet these people at OHBM and I'll have a new collaborator. And I think it's much like meeting friends in your own social life. I mean, you don't really plan it. Now, that's both a relief, but a bit stressful. So I think, for junior researchers, I used to not like conferences because you don't know many people and you're very nervous. And when you're older, you're lucky, you know a lot of people. So I think, building collaborations, maybe people start with their own paper or their own method, meet some people that might have complementary interests. If you're a neuroscientist, there might be someone studying a related data set that you could work together with. But I think these things grow very, very gradually. And the other way to do it is you have this giant consortium and someone says, I have an idea. A few of us here are doing that. But I think that's unusual. And maybe for the junior folks starting out, is it fair to say, maybe Wei, you have an idea that I think it's more random than planned, but maybe there's other ways.
No, I completely resonate with what you just said, right? When you just enter the field, it's so intimidating to approach to anybody. So you recognize some big names in the crowd, surrounded by other crowd. How I'm gonna get through it? So that it is quite difficult. So I think in related to this, then as a mentor, what support do you think you should provide to your mentees on this front?
Okay, so for example, Dr. Seokjun sitting there, he once was my PhD student and a postdoc. So as a mentor, what I need to give support is now he is visiting at the CEMH, Canada in Toronto. So as a mentor, you need to provide maybe grant support, maybe money support for them to at least go to HBM. You need to provide the travel fees to let them to meet people. And second, if they are interested in some abroad institutes, because I have other students, they institute in other institutes, so need to give the grant or get money supported them to visit 2 years or 3 years. They automatically will form new collaborations, have new networks, I think, from the mentor perspective. But at least myself is still early stage, I guess. At least several years ago, I'm early stage. So we have some collaborations because we have lots of software users, and then we ask them donate their data pre-processed by our software. So we gather the depression brain imaging data. That's kind of mechanism from crowdsourcing software to crowdsourcing data. So they're using your software. You ask them some feedback or some reward that give me your data. So we start from there.
I actually just second what Chaogan said. Actually this OHBM, I send my student to hackathon I actually ask him to, rather than joining other groups, just suggest your own project, and he ended up with being too much shy, so that just joining to other groups. But then I think one should just contact to, no matter how big name is or middle name is, so that just be aware of those people who is doing the research, and then slowly getting interested in the field. That's, I think, one way to.
Do you have anything to add, Francesco?
Yeah, I think joining conferences is extremely important, and there are communities at very levels. So, of course, there are the big conferences where all the big people go, and there are thousands of attendees, and it can be intimidating. I remember myself being intimidated by the big conferences, but there are smaller meetings, there are smaller communities that are maybe more focused on a specific topic that you're working on, and they're more accessible to early career researchers. So actively seek for these smaller communities and enter there, and they will be the gateway then to the broader community and the big stage. And of course, the mentor has also a big responsibility of taking care of their students and not just going to the conference and disappearing from their students to mingle with their peers, but actually integrating the PhD, the postdocs, introducing them to people who work on the same field, but they might not be so easily accessible.
Right. Okay. Then, so every speaker as established researchers, right? Oh, sorry. Go ahead.
I mean, one bit of advice I always give to my PhD students is to work with people that you enjoy working with, and it does make the process of collaboration so much simpler. I guess that's not always possible when there's.
How do you identify that this?
I mark people out.
Oh.
No, I don't. But yeah, I do wonder. There must be a stage when actually there are pragmatic reasons and the strategic reasons why you work. But initially, I definitely think find peers and collaborators that don't drain you. That the process becomes easy.
Okay, next question is more for mentor themselves. So all of you as established researchers in the field, you must do a lot of collaborations as well. So how do you balance your time? Because at your own institution, you must have all other services you need to provide. You have students. Now how to expand your efforts or energy or time or resources to cover the other side, to do all the collaborations?
Yeah, that's a great question. So a good collaboration should save time. So let's say we're stuck. And I know maybe you guys can help with some of the problems that we're doing. And now that's not always possible. So I used to go to conferences and everyone I met would ask me to do something. And I'd go home thinking, well, no, I have a lot more to do than I came to. And that was a bad way of doing conferences. But I think you make a very important point, because if you have a role in a team and this just endlessly proliferates, I mean, you can do 10, 20 projects, and eventually you get very anxious and depressed and stressed. And I don't want to minimize that. I mean, I got really overwhelmed with collaborations because we have a lot of collaborations. And I bought a book about how you deal with overwhelm. It is a very good book. How do you deal with overwhelm? And do you deal with overwhelm? That's another lecture. I'll tell you how I do. But it's interesting because when you have a lot of collaborations, there's the implicit assumption that you're available to help all of them. And Ilya, you and I and Leah talked about this at lunch. When you support software or you support a pipeline, you're suddenly at the front desk of a hotel that is overcrowded with people and they're all sort of irritable and angry. And so I think, you make a very important point about collaboration. The first part of this discussion, we said how great collaboration is and we should promote it and it is helpful to the field. But there's a hidden sort of emotional burden of being available for all of these people. And for junior people, that's extremely difficult. I mean, you can't tell people I'm not answering you. Well, you can. So I think for researchers at every level, you have to sort of take a step back and look at your list of collaborative obligations and almost do a self-check-in, like a wellness check-in, and say, is this collaboration helpful psychologically? Is the intellectual value, who was it that said a collaborator can be draining? You said it. So that's important. I mean, maybe you look at the list of things and you think, well, I've taken on too much. There's too many collaborators, too much email. I have a role in this project that is too much of a support role. I can't get a visible role in these things. These are all things that we deal with all the time. And I have to say it can become absolutely overwhelming. So I think you need a good mentor. You need people that you can vent to. I mean, maybe you met people at this conference that you sympathized with. But also you can give yourself a little bit of a break, because I think you made a very important point. Collaborations do take away time from other activities that you might want to do, including maybe resting or work-life balance. I mean, we're not out here to collect the longest list of collaborators that we could. I mean, it would be just overwhelming. So I think maybe mid-career investigators need to spend time on work-life balance, time management, saying no, which is difficult for all of us to say no, and even sort of taking a step back from your academic life and trying to sort of rank and consider the different choices that you've made, because avoiding stressful collaborations is also as good as creating new and helpful collaborations. Do you have any?
Before entering question, a short comment on Paul's that for software Q&A, that will be a lot of duties. But once you create a user group, more than 3,000 people, they will help each other. So those very entry-level questions, they will answer with each other. So you do not need to put too much time on that. So create the community is important for that part. So now entering the question is how to balance. Yes, I do have teaching duties and institute administrative duties and other social service a lot. But always the most important thing is more students. So in our lab, we have lab meetings twice a week. So maybe Tuesday and Friday, and we have twice a week. And on each lab meeting, each student should report what they are working on and what's their problem. And I will give comment on that. So I will full committed to my time to fulfill that. I need to show up twice a week and discuss with them. So that's the most important thing. And another thing is interesting, our lab has a website or an app. The app is the daily management that we can assign tasks for them. But the most usable is not the task management system, is a daily report system. So by the end of the day, they will write what I have done today, what kind of problems, and I will receive the emails what they wrote, and if there's an urgent need I need to adjust, I will reply them. But this is a good system that for them, every day you need to wrap up my day and what's the questions and what I need to do tomorrow. And so this is how our lab running. And another question is that how to balance research and collaborations. So in our lab, the collaborations is pretty simple. So once there's a collaboration, we always have a student lead that collaboration. For example, for the ResMMDD data set, that mostly by myself, but there's a student in charge of that. And currently for the TMI's collaboration, there's a student in charge of this. He will coordinate all of the collaborations. And another project like we want to build a human brain by 200,000 brains. So there's a student, we will coordinate that. So actually it's most the work is done by the individual students, and that's all there will be their thesis. So it's the collaboration and the research is just integrated in our lab. So that's a balancing.
I just add short a note here. First of all, it's really interesting to see how our conversation continues, starting from crowdsourcing to balance. It's interesting. For me, if there is a criteria to choose whether I should collaborate or not, what I consider mostly important is whether I and opposite side can give what we can give each other. So that paradoxically, collaboration need also incentive each other. Otherwise, I found myself that this collaboration like just stop in the middle of the process. But I think whenever I try to collaborate, I first think about what I can give the opposite, and then the opposite also can give me, so that make clear that. And then I think this process probably make whole entire process rather healthy, rather than thinking, who's going to take the authorship, of course, being behind. So that I think that's one.
So we're almost time. Francesco, do you have anything to add so we can close our conversation?
No, thank you. I think everything has been said fantastically, and I'm.
So you have no
really
issues balancing your own time doing research?
Well, I do have a trick for you, and it will take a minute to explain,
Sure.
and then I will. Everybody will hate me. So whenever I have encountered a lot of people that come to me and say, "Let's collaborate," and what they mean is you do the work, and I never say no to them, and this is the trick, but. I always tell them, look, this is a fantastic idea. I think we should definitely do it. But first, please do this. So I always give them a task before I say, I actually start working on their project. I said, yeah, no, this is great. I'm totally on board. Of course, I will look into that, but you do this small thing first. And if they're really motivated, they will go and do the thing. And then you say, okay, then these people are really interested in collaborating. If they just take then 5 months to come up with half a paragraph proposal or a draft for an ethics application or whatever you give them, then you immediately see that they're not a very good collaborator and they just want to lead your time. And so you can give them another small thing, and it will take another 5 months, and then you almost finish your
That's a
your
very
time
good
there.
advice to filter out spammers. I saw someone come here.
I ask a general question. So I have been using ChatGPT to help me to learn about some software, and I noticed that for some software like R or Python, ChatGPT is really good at answering my question. But for some certain softwares, ChatGPT seems not so helpful. And so my first question is, I'm wondering why there is differences, and is there anything we can do to make this kind of model, this AI, more clever for our softwares? And the second question is that is there some way we can build our own AIs to help us to answer the questions about this software?
I think there could be probably many different ways. I think it's going to come up in the future, but for the moment, what it hit my mind is like federated learning type of algorithm, like, because I'm actually working on clinical neuroscience, particularly epilepsy. And then in epilepsy field, we often need the lesion segmentation labels, which require this labels segmentation effort. And then the reason why we need this data set is often to train the AI algorithm based on this segmentation label. And then the thing is, those clinicians unfortunately do not really want to share this label, because this is quite laborious. So that in federated learning, what it provides you is to, rather than letting them provide their data, if there is already some kind of algorithm that they can decentralize, and then using their own data set, they train and then only send this weight. Like if this is artificial neural network, then only send this weight information to centralize to build up like finer outcomes. But I think in that sense, it sort of the fact that those clinicians do not want to share the data set first. And then the other one is clinical data always require this privacy information issue, that it also addressed this question. So this is just one example, so that I think AI will obviously, I mean, as we all know, that will transform all this brain imaging research also. I really look for what's going to happen in the future.
Okay, yeah, we are already over the time, so we'll have to close the session. Please join me. Thank all other speakers, also the speaker online, for this fantastic discussion. And also thank you for coming.